One final example of working with these rational integrals. X plus 3 over x to the fourth plus 3x squared minus 4. Numerator's degree is less than the denominator's degree. So we're just going to decompose it by factoring the denominator, as we have multiple times. So we get x plus 3. This is going to factor nicely into x squared plus 4, x squared minus 1. And notice that the x squared minus 1 is a difference of squares to which we can factor again into x plus 3. We keep the x squared plus 4 because that's a sum of squares. And then we can say x plus 1, x minus 1. Right. Now, as you can see, we have a quadratic term, and then we have two distinct linear terms. So what that means to us is that we're going to have to decompose this using three partial fractions, two of which are linear, one of which is quadratic. So we're going to have the following: x plus 3 divided by what we just got, x squared plus 4, and then x plus 1, x minus 1, keeping in mind that x plus 1, x minus 1 is the same thing. Just keep in mind that that's the same thing as x squared minus 1. And that might help us a little bit later throughout the problem. All right, so we have that. We're going to have one linear term, all right, and the linear term is going to be a over x plus 1. We have another linear term, which is b over x minus 1. And then we have the cx plus d divided by the x squared plus 4. If we multiply everything through by the common denominator, that's going to wipe out a whole bunch of stuff. Okay, so that's going to leave us with x plus 3. And then the a, notice that we have x plus 1. So that's not going to be part of our product. So that's going to be x minus 1 and then x squared plus 4. Notice in the b that we have x minus 1 in the denominator. So that's not going to be part of our product. So we're going to have x plus 1, x squared plus 4. And then finally, we have cx plus d, and the x squared minus 4 is not going to be part of the factor or a factor. It's not going to be part of the product. So that means we're going to have x plus 1, x minus 1, which we already said is the same thing as x minus 1 squared. All right, and I'm just going to write it in that form because it's a little bit easier for us to work with. Now, this would be rather difficult for us to work with if we were going to do the system method. However, let's do the method where we pick nice numbers, and let's hope that this works out okay. And it should work out okay for a few of them. One of the nice numbers I can pick right away is 1, all right? Because I noticed that that'll cancel this, and that'll cancel this term out. So it'll cancel out the a and the cx plus d, and this should be an x squared minus 1, excuse me. And so that's going to make it nice that we can find b really quickly. So when x is equal to 1, this is going to become 4, and then we get b times 2 times 5, so that would be 10b, or in other words, 2/5 is equal to b. All right, so that was nice and easy to find one of them. Let's try another one. This time, let's try x equals -1. And what that's going to do is that's going to eliminate the b term. Okay, so if I plug -1 in here, -1 plus 1, that's going to get rid of all this. Okay, so that's nice. And then -1 squared minus 1 is also 0, so it's going to get rid of that term. All right, so the b, cx plus d are both going to go away, or all going to go away. And we're going to wind up with 2 on the left-hand side. Right, positive 2. I know it looks like a -2. All right, there we go. And then the rest of what's left, that's going to be a -2. And then if we sub in a -1 here, that's going to be 5. So that's going to be -10a. Oh, I think I plugged it into the wrong one. Over here, that's going to be -2. if I substitute x equals -1. And this is going to be a 5. So we're going to get negative 10a. And that's going to be a negative 1/5 is going to be equal to a. All right, so that's helpful. All right, now we have to do a little bit more of the dirty work. All right, so I'm going to back substitute the 2/5 and the 1/5. All right, and let's go ahead and do that. So this is going to become x plus 3 equals negative 1/5, x minus 1, x squared plus 4. And then we have the 2/5, x plus 1, x squared plus 4. And then we have the cx plus d, and that's going to be x squared minus 1. All right, so now we can go ahead and substitute 0 back in for x, and that'll get rid of the cx, and that'll just leave us with d. All right, so if x is equal to 0, that's going to give us 3. We're going to get negative 1/5 times negative 1 times 4 plus 2/5 times 1 times 4. That's cx plus d. C is going to cancel, and we're going to be left with minus d. All right, so we substitute 0 back in here. We just have a negative 1 and the d. All right, so let me get rid of this because we are going to reuse that. The nice thing is that d is going to be readily computable. All right, what I'm going to do is I'm going to multiply through everything by 5. All right, just to clean this up a little bit. So actually, I'm not. I'm just going to add the terms together. I didn't realize that multiplying it by 5 means I have to divide by 5 at the end. So this becomes 4/5, and this becomes 8/5. All right, so that's going to be 12/5 minus d. All right, if we subtract from both sides, we're going to get 3/5 equals negative d. So negative 3/5 should be equal to d. All right, so there we go. And then the last thing we have to do at this point is solve for d. Now that's going to be the tough one because realistically, there's no nice number that we can plug in at this point. Okay, so let's see what happens with this. So if I substitute back in, let's say we already did 1. Let's try 2. I know it's not the best number, but it's probably not the worst number we could choose. And what we can also do is substitute back in right here, negative 3/5. That's going to help us to evaluate for C. All right, so we get 5 on the right side. If I was smart, I probably would have picked 6, but because then it would be 6 minus 1, and the 5s would cancel out, at least for this one, but it doesn't always work. So that's going to be negative 1/5 times 2, or times 1, excuse me. So it's 2 minus 1. And then we have 2 squared plus 4, so that's going to be an 8. And then we're going to have 2/5 times 3 times another 8. We still have cx plus d minus 3/5. So we have plus our cx plus d. And remember that x was 2, so it'll be 2c minus 3/5. And that's going to be equal to, or times 3 when we do this. Okay, so this time I am going to multiply through by 5 to clean up the denominators. So that's going to be 25 equals negative 8 plus, that 5 is going to cancel if I multiply through, and that's going to be 48, I believe. And if I multiply through by 5, this is going to become a 15. So we wind up with 30c minus 9. All right, just by distributing this. All right, and it actually works out okay, I guess. Could be a lot worse. So this is going to be negative 8. That's going to be a positive 40. 40 minus 9 is going to be a 31 plus 30c. Almost there. negative 6 over 30 equals C, or in other words, negative 1/5 equals C. All right, so that was pretty painful, but it is what it is. We had to go through and get to it. All right, so the good news is now we can substitute everything back in to our original integrand right here, okay, or actually into our partial fractions. So we said a was negative 1/5. So now we're going to get the integral of negative 1/5 over x plus 1 dx. And we had b, which was 2/5, and that was over x minus 1. So those aren't too bad. And now we have the cx plus d. So that's going to be negative 1/5 x. So that's cx. And then d was negative 3/5. That's negative 3/5 over the x squared plus 4 dx. All right, so the first two integrals, not so bad. In fact, really easy to try to compute. All right. The problem is trying to evaluate this animal right here. All right. Excuse me. It's not a U substitution. The way that we're going to have to evaluate this is to break it up into two separate integrals. All right. So I'm going to hold on to this and I'm going to hold on to this because I know what those are already. That's negative 1/5 ln absolute x plus 1, and then positive 2/5 ln x minus 1 plus c. Okay, so that's going to be part of our answer. But to finish this off, evaluating this guy right here, we are going to have, and I'm going to leave a space because then I'm just going to fill in the other stuff. That's going to be negative 1/5 integral of x over x squared plus 4 dx, and then minus 3/5 of the integral of dx over x squared plus 4. All right, and that's going to be the remainder of the answer. To evaluate the first of these two, U substitution. That's not too bad. Okay, so U is going to be equal to x squared plus 4. Du is going to be equal to 2x dx. And so du over 2 equals x dx. So our integral is going to become integral of du over 2 divided by u. We can factor out the 1/2, multiply it through. So that's going to be negative 1/10. We'll be left with du over u, which is going to be natural log of u. And then finally, we back substitute the x squared plus 4. So that's going to wind up being negative 1/10 ln absolute x squared plus 4. And that'll be part of our answer. Okay, so we go up here. So now we have a negative 1/10 ln absolute x squared plus 4. All right. The last thing we have to do is we have to evaluate this guy right here. Okay. And the good news with this one is it's just going to be a basic function. It's an arctan. Okay. So this is going to be minus 3/5. And we're going to have arctan of x over 2, in this case, a, is equal to 2. And by the way, where I'm getting this from, just to make sure you all understand, if I go into my Blackboard page, just to show this really quickly, if you go to that list that has all of the, if you go to files and documents, or the examinations, sorry, if you go to the examinations, or sorry, exam reviews, and the reference card for the examinations, there should be the integral of du a squared plus u squared. Now in this case, a is 4, or a squared is 4, so a is 2, and then u squared. So this is going to be 1 over a arctan of u over a plus c. So in this case, a is 2 and u is x. So when I'm figuring this out, I still need a 1 over 2 arctan of x over 2. And so this is going to be negative 3/10 arctan of x over 2. All right. And finally, I'm just going to bring that up here. And that would be arctan of x over 2. We already have the plus c. It doesn't really matter where it goes. All right. So this is going to be our answer. Of course, we could use the various rules of logarithms to combine it into, those three into a single logarithm if we elected to. I'll let you do that if you want to. And then we would still have that negative 3/10 arctan x over 2. All right. So that's everything for these rational sorts of integrals. Clearly, they're pretty rigorous to do because of the partial fraction decomposition. So make sure you're good with your algebra when you're doing this, and keep in mind the rules for the integral of the ln function, or the du over the linear sort. It's going to be very helpful when you guys are evaluating these.